It is the year 2025. Stop and look around. The world we live in today would have seemed like science fiction just a few generations ago. There are more than 8 billion people on Earth now. People live on every continent, even in the coldest and driest places. No matter where you are not truly alone. That is something new in human history. You can talk to someone on the other side of the planet in just a second. You can see their face on a screen, hear their voice in real time, laugh together even if they are 10,000 miles away. 100 years ago, this was impossible. 100 years ago, a message could take weeks to reach someone. Today it takes less than the blink of an eye. We have built machines that can think. Not think like us, not exactly, but they can solve problems, understand language, learn from experience. These machines, called artificial intelligence, are already helping doctors diagnose illness. They help planes fly and cars drive. They write music. They play chess better than any human being. Some people say they are only tools. Others fear they may one day outgrow us. No one knows for sure yet. Diseases that once killed millions are now under control. Smallpox, once one of the deadliest threats to humanity, has been wiped out. Polio is nearly gone. Doctors can replace failing hearts. They can even edit genes to fix inherited conditions. Life expectancy is longer than it has ever been. In some countries, babies born today are expected to live past 100. That too would have seemed like a dream not long ago. This is what we have achieved. This is where we stand. It is easy to feel proud. It is also easy to feel uneasy. Because for every step forward, we find new questions waiting. Some of them are hard. Some of them are frightening. Our planet is heating up. The ice at the poles is melting. Forests are burning faster than they can regrow. Weather is changing. Floods, storms, and droughts are becoming more common. Scientists warn that we are changing the Earth in ways that may not be reversible. We do not yet know how far this will go, but we know we caused it. That is hard to face. We look up at the stars and wonder if we are alone. So far, we have found no sign of life anywhere else. Just silence. The universe is huge, maybe even endless. That makes the silence even louder. Why has no one answered? Or are we just not listening the right way? The more we learn about space, the more it makes us ask these deep questions. Technology is racing ahead. Every year, we invent faster computers, smarter machines, and better tools. But some people worry that we are running too fast without knowing where we are going. Can technology solve all our problems? Can it teach us how to be kind, how to be wise, how not to destroy each other? There is fear beneath our progress. Fear that we might build something we cannot control. Fear that we will use our power not to build, but to harm. Some experts say that we are the first species with the power to destroy ourselves completely. We have weapons that could wipe out cities. We have the tools to spread lies faster than truth. We have systems so complex that no one person fully understands them. This is not fiction. This is now. And so, we come to the purpose of this journey. We are not just looking at what we can do. We are asking what we should do. Why does it matter? Because every great society in history believed it could go on forever, and none of them did. The Roman Empire fell. The Maya cities were abandoned. Ancient Mesopotamia, once a world leader, became dust. They built, they grew, they conquered. But they also ignored warnings, failed to adapt, and ran out of resources. Every civilization has limits. Reaching them can mean the end. But here is the difference. We are the first civilization with the power to see our limits coming. We have science. We have history. We have global communication. We can learn from the past instead of repeating it. That is our chance. If we understand our limits, we can make better choices. Choices about how we use technology, about how we care for our planet, about how we treat each other. These are not easy questions, but they are necessary ones. What is possible? What is impossible? What is wise? These are the questions that shape the world to come. The answers will decide how our children live, and their children after them. This is not just a story of science or machines. This is a human story. It is about meaning, about direction, about hope. So we begin here, with a clear-eyed look at where we are, with a sense of wonder and a deeper sense of responsibility. We have come far, but the road ahead will ask more of us than ever before. And the first step is to ask the right questions. There is only one Earth, no backup planet, just this one. For most of human history, Earth felt endless. The forests seemed infinite. The oceans felt deep enough to swallow anything. The sky was clear and the rivers flowed cold and clean. But today, we know better. We are starting to see what happens when we ask too much from our planet. The cracks are showing. And some of them are growing fast. Let's begin with water. Clean, fresh water. It is something most of us take for granted. Turn a tap. Fill a glass. Take a shower. But in many parts of the world, that tap is dry or the water is not safe. Rivers that once flowed year-round now dry up during hotter months. Groundwater stored deep under Earth's surface is being pumped out faster than it can refill. This is not just about drinking. Farms need water to grow food. Factories use water to make products. Without water, everything stops. Already in places like Cape Town in South Africa and parts of California in the United States, water shortages are no longer warnings. They are real. Next is soil. It is not just dirt. Good soil holds water, feeds plants, and supports insects and tiny life forms that help crops grow. But our soil is wearing out. When we plant the same crops over and over without giving the land time to heal, the soil becomes weak. Wind and rain carry it away. In some places, it takes nature hundreds of years to make 1 inch of new soil. We are losing it much faster than that. No soil means no food. It is that simple. Then there are the fuels we use to power our world. Oil, coal, natural gas. These took millions of years to form. We burn them in just seconds, and one day they will run out. Even before that day comes, we face another problem. Burning these fuels fills the air with gases that trap heat. That heat is changing everything. Yes, we have renewable energy, solar power, wind power, water power, but these also have limits. Solar panels need sunny skies. Wind turbines need steady winds. We need metals and minerals to build them, and those come from the earth too. Nothing comes without cost. This brings us to the biggest warning sign of all, the climate crisis. The earth is getting hotter. That is not a guess. It is a fact. The last 8 years have been the hottest ever recorded. This heat is not just about temperature. It is about survival. Some places are becoming too hot for people to live in safely. In parts of the Middle East and South Asia, heat waves reach levels that can kill within hours. Air conditioners help, but not everyone has them, and they rely on electricity, which comes from energy we are still figuring out how to make cleanly. Sea levels are rising. The ice in Greenland and Antarctica is melting. As the ocean swells, it pushes into coastal cities. Places like Jakarta, New York, and Miami are already seeing streets flood more often. Entire island nations like the Maldives may disappear. These are not far-off threats. They are happening now. Farming is also changing. Weather is less predictable. Rain comes too much at once, or not at all. Crops that once thrived in a region now struggle. Farmers in Africa, Asia, and even parts of Europe and North America are having to change what they grow or leave their land behind. All of this leads to one big question. How many people can Earth really support? Scientists call this the carrying capacity. It is the maximum number of people Earth can hold before the systems that support life begin to break down. Most experts agree that number is somewhere between 9 and 12 billion, but it depends. It depends on how much each person uses, on how we grow food, on how we share space. Right now, there are 8 billion of us. We are not just filling up cities. We are spreading into wild lands. We cut down forests to grow crops. We build roads through jungles. We fish the oceans faster than they can recover. Every new town, every new factory takes space away from something wild. More people often means less nature. We have to make a choice. Keep growing or keep Earth alive. Maybe there is a middle path, but it will not be easy. The hardest part of this story is what scientists call tipping points. These are the moments when something breaks and cannot be fixed. One example is the ice in the Arctic. Ice reflects sunlight, water absorbs it. As the ice melts, more sunlight hits the ocean, making it warmer, which melts more ice. At a certain point, this loop cannot be reversed. The ice is gone, and with it, the balance that kept global temperatures in check. Another example is the Amazon rainforest. It produces its own rain, but if too much of it is cut down, it stops doing that. The trees die, and the forest becomes a dry plain. Not just a local change, a global one. Once a tipping point is crossed, the damage spreads. One broken system leads to others breaking. The planet becomes less stable, less safe. Some scientists believe we are already close to several tipping points. Some say we may have crossed them already. The truth is, we do not know for sure, and that uncertainty is a danger in itself. So here we are, one planet, 8 billion people, rising heat, shrinking resources, a race between growth and collapse. Every person alive today carries the same basic body and brain design as people did thousands of years ago. Our world has changed. Our tools have changed, but we have not changed that much inside, and that matters. There are things the human body simply cannot do, no matter how much we wish it could. Take speed, for example. The fastest a human has ever run is about 28 miles per hour. That is faster than a car in a city, but much slower than a cheetah. The reason is simple. Our muscles, tendons, and bones work together in a certain way. They can only handle so much force and movement at once. Push harder and the muscles tear. The bones break. There is a limit built into our bodies. Our brains, even though they feel endless, also face hard limits. The brain is only about 2% of our body weight, but it uses 20% of the energy we burn every day. That means it is already pushing close to the edge of what our bodies can support. A bigger brain might seem like a path to greater intelligence, but it would need more energy and a larger skull. Our bodies cannot easily handle that, so evolution made a trade. We have smart enough brains, not perfect ones. Then there is time. We age, we die. This too is built in. Every cell in our body can only divide a certain number of times. After that, it stops. The ends of our chromosomes, called telomeres, get shorter with each division. When they wear down too much, the cell becomes old or damaged. It stops working well. Aging is not just wrinkles. It is the slow falling apart of all our parts. No matter how healthy we eat or how often we exercise, the process continues. And beyond aging, we are fragile. Gravity pulls on us every second. It holds us in place. But in space, where gravity is weaker, our bones thin and our muscles shrink. The body does not know how to stay strong there. And space has other dangers. Radiation from the sun and beyond can damage our cells. Extreme heat or cold can stop our organs. Our bodies were built for Earth. They do not do well anywhere else. Then there is the mind. We often speak as if the human brain is the most powerful thing in the known universe. It might be, but even it has limits. Our memory is flawed. We forget most of what we see, hear, and feel. Some memories fade in days, others twist over time. Our brains are not recorders. They are more like storytellers, shaping what we remember based on what we believe or feel. We also cannot focus on many things at once. People say they are good at multitasking, but science says otherwise. Our attention can only truly lock onto one or two things at a time. Try to do more and mistakes happen. We miss details, we get tired, we lose track. Our emotions, which help us care and connect, also get in the way. Fear, anger, love, pride. These feelings push us to act. But sometimes they push us in the wrong direction. We make bad choices. We know better, but we act on impulse, or habit, or fear of loss. This is not weakness. It is part of being human. And then there are problems that are simply too complex. Problems with many pieces, many causes, many unknowns. Our brains can follow a few steps at a time, but if there are hundreds of moving parts, we lose the thread. We oversimplify or we give up. Our minds, like our bodies, were shaped for simpler times. This brings us to a big question. Can we go beyond these limits? Science is trying. Some researchers are learning how to edit human genes. That means changing our DNA before birth to remove diseases, or even to boost traits like strength or memory. Others are testing ways to add computer chips to the brain. These could help people with injuries or maybe someday boost memory or thinking speed. There are scientists working on ways to slow aging, to help people live far longer. Some even speak of people living for hundreds of years. It sounds like science fiction, but it is already beginning. Still, every step forward raises new problems. If only rich people can afford enhancements, what happens to fairness? If we live far longer, what happens to jobs, to housing, to population? If we change our brains too much, are we still the same people? The future may bring answers, or more questions. And even if we change the body and the brain, there is still the question of how we live together. Humans were shaped by evolution to live in small groups, families, tribes, maybe a few dozen people who hunted, gathered, and cared for each other. That is how we survived. Now we live in massive cities, nations with millions, even billions of people. The world is connected like never before. But our minds are still tuned for small circles. This creates stress, loneliness, conflict. Large groups can be less wise than individuals. When too many people try to make a decision together, noise and pressure often drown out clear thinking. Leaders can take power not because they are right, but because they are loud or charming. We also struggle to care about things that are far away. A child crying nearby touches our hearts. But a flood killing thousands in another country can feel distant. We are built to care deeply for what we can see and touch. But our problems today are global. Climate change, disease, war. These require care that stretches across oceans and cultures. That is not easy for the human mind. We also need meaning. More than food, more than shelter. We need to feel that life has purpose, that what we do matters. Every culture finds its own answer to this need, but it shapes everything, how we act, what we build, what we fear, and what we hope. That need for meaning may be one of our greatest limits, and also our greatest strength. So where does this leave us? With a body that wears out, a brain that forgets, emotions that mislead us, a social mind made for small groups. And yet, we dream, we imagine, we reach. The limits are real, but so is the drive to push past them. We may never be perfect, but we are curious and brave and stubborn. Those traits, more than any machine or medicine, may shape what comes next. There is something beautiful about human curiosity. We look at the stars and wonder what they are. We break rocks open to learn how Earth was born. We ask questions about everything we see, feel, and even dream. This curiosity has taken us far. It gave us fire and wheels. It led to flight, electricity, space travel, vaccines, and the internet. But now some scientists are starting to ask a new question. What if we are getting close to the edge of what we can know? It is a quiet, unsettling thought. Not because we are lazy. Not because we have stopped trying, but because nature itself may have limits that we cannot break through. And those limits may already be pressing in around us. Let us start with something called the low-hanging fruit problem. In the early days of science, big discoveries were easier to make. The Earth orbits the sun, germs cause disease, matter is made of atoms. These truths were always there, but no one knew how to look. Once we learned to ask the right questions, answers started to appear. The fruit was hanging low. All we had to do was reach out and pick it. But that phase is mostly over. Now discoveries take more time, more money, and more minds working together. Think about the Large Hadron Collider. It is the biggest machine ever built. Its job is to smash tiny particles together to understand the basic laws of physics. It cost billions. It took decades to build. Thousands of scientists worked on it, all to find one particle called the Higgs boson. We did find it, but now what? Some say we have already discovered most of the major laws of nature, that the basic framework of physics, chemistry, and biology is mostly known. There are still questions, yes, but they are deeper, smaller, harder. Like the last pieces of a giant puzzle, they do not give big surprises anymore. Some scientists compare this moment to a mapmaker who has drawn all the continents. The shapes are known, the edges filled in, there is less left to explore. But the problem is not just effort, it is also nature itself. The universe plays by strict rules, and some of those rules are hard walls we cannot break. Nothing can go faster than the speed of light. That is not a technical limit, it is a physical one. Even the fastest spaceship would take thousands of years to reach the nearest star. This makes travel to other worlds extremely hard. It makes quick space communication impossible. Another rule is energy. You cannot make it from nothing. That is the first law of thermodynamics. You can move energy, you can change its form, but you cannot create it. That is why there is no such thing as a free lunch, not even for the universe. Then comes quantum mechanics, the science of the very small. Here, things get strange. A particle can be in two places at once, but the moment you look, it chooses just one. The better you measure one part of it, the less you can know about another. This is not a flaw in our tools, it is how nature works. There is a hard limit on what we can know at the smallest levels. These are not problems we can fix with better machines. They are the structure of reality itself. Then there is the issue of complexity. Some problems are not blocked by physical laws, but by the way information behaves. Take the weather. We have satellites, models, and computers, and still forecasts get it wrong. That is because weather involves billions of moving parts. Tiny changes in one place can lead to huge differences later. This is called chaos. Even with perfect data, the system is just too wild to fully predict. The same is true for ecosystems, economies, even the climate. We can build models. We can try to guess. But perfect knowledge may always stay just out of reach. The brain is another example. It is the most complex thing we know. 100 billion neurons, trillions of connections. Even though the brain is inside our own heads, we still do not fully understand how it works. We can scan it, we can study it, but its total picture may be beyond our reach. Artificial intelligence may hit the same wall. Yes, AI is fast. It can read, write, solve, and learn. But when a system has too many layers, too many factors, even an AI may struggle. The problem is not speed. It is depth. Some problems are just too tangled, and so science slows down. This brings us to diminishing returns. In the past, progress was fast. The light bulb, the telephone, the airplane, big leaps one after another. But now, each new step forward costs more. Each new drug takes years of testing and billions of dollars. Each new computer chip takes extreme precision and rare materials. Each new idea must pass through endless filters of review, funding, and approval. And the rewards grow smaller. We cured smallpox. We tamed polio. We found antibiotics. But now we face diseases that are harder to solve. Rare cancers, genetic disorders, mental illnesses. The easy cures are mostly behind us. The same is true for energy. Early machines ran on steam, then coal, then oil. Now we reach for solar panels and wind turbines. They work, but not everywhere, and not all the time. Batteries are improving, but slowly. Fusion power is still not ready. Each step forward takes more time, more risk, and gives us less in return. So we ask again, are we reaching the end of what we can discover? Maybe. Or maybe we are just in a long pause, waiting for a new tool, a new way of thinking, a new Einstein. But we must be honest. Discovery is no longer fast or easy. Nature is guarding its last secrets closely, and we are beginning to feel that weight. Still, this is not a reason to give up. It is a reason to think more carefully, to be patient, to be humble. Not all ceilings are final. Some can be lifted slowly with the right kind of pressure, with creativity, with questions we have not yet learned how to ask. Science is not a race. It is a light in the dark. Even if that light grows dim, it still matters. Technology has brought us far. Machines can now think, talk, even learn. They build our cities, power our homes, and fly us across oceans. Some explore deep space, others fit in our pockets. Many believe there is no end to what technology can do. But what if there is? Not because we stopped trying, not because we gave up, but because we may be reaching the true edge of what is possible. That edge is not made of fear or failure. It is made of laws, the rules of nature, the shape of reality. Let us start with the heart of every machine, the computer. Computers have grown fast, very fast. In the last 70 years, they became millions of times more powerful. Smaller chips, faster speeds, more memory. But now that growth is slowing. There is a reason. Every computer chip is made from tiny switches called transistors. These switches turn signals on and off. They are what let computers do math, store words, and play videos. For years, we made them smaller and smaller. But now we are reaching the size of atoms. And atoms are the smallest parts of matter we can work with. When switches get that small, strange things happen. Electrons can jump in ways we cannot control. Heat builds up too fast. Mistakes happen. It is not a problem of money or tools. It is a problem of physics. There is just no room left to shrink. Some scientists are working on a new kind of computer, one that uses quantum mechanics. These are called quantum computers. They do not just use ones and zeros. They use something called qubits, which can be both at once. This lets them explore many solutions at the same time. Quantum computers may one day crack problems too hard for regular computers. But even they have limits. They are fragile. They make errors easily. They are good at only some types of problems, and building them takes extreme care and energy. Not every hard question can be solved with a quantum shortcut. In fact, some questions may be impossible to solve, no matter what computer we build. Imagine a puzzle so large, so complex, that even a machine using every atom in the universe as a processor would not finish it. These puzzles exist. We know them from math. Some are about how to best pack shapes. Others are about how to predict the future of a chaotic system like weather. They do not just take a long time, they take more time than the universe has. And then we come to artificial intelligence. Right now, AI is impressive. It can read documents, translate languages, write stories, paint pictures, and drive cars. But under the surface, it is still pattern recognition. It finds links in data, it copies styles, it guesses what might come next. It does not think the way humans do. AI is powerful, but narrow. It is trained to do a task, and it does it well. But it does not understand. It does not know what it knows. It cannot explain itself. It cannot feel. It cannot dream. Some experts believe we will one day build a machine with true general intelligence, one that can learn anything, reason deeply, and maybe even become aware of itself. Others are not so sure. Training advanced AI takes vast amounts of data, more than any person could ever read. It also uses huge amounts of energy. Every new model requires bigger computers and longer training times. We are already hitting walls of power, time, and cost. And even if we get the hardware right, the question remains: can machines be truly creative? Can they have original thought? Can they want? Can they care? We do not know, and we may never know. Technology also depends on what we can build. That means materials, and even there, limits exist. At the atomic level, matter is made of atoms held together by forces. Those forces have rules. You cannot make a rope stronger than the forces that hold atoms in line. You cannot make a beam lighter and thinner without risking collapse. Every material has a maximum strength, a breaking point. No matter how smart we get, we cannot change the laws of bonding between atoms. Some materials, like carbon fiber or graphene, come close to perfect strength. But they are costly. They are hard to make in large pieces. They still break just under higher pressure. Engines, too, face boundaries. A perfect engine would turn all its fuel into work, but that is impossible. Some energy always escapes as heat. This is a law of thermodynamics. Solar panels also have a ceiling. The best ones can only capture about 1/3 of the sunlight that hits them. That is called the Shockley-Queisser limit. And even that is only in perfect lab conditions. Physics draws lines. Even if we have the best material on Earth, we cannot build a bridge across the sky. We cannot float cities in space without using vast energy. We can dream, we can try, but we are still held in by gravity, heat, and pressure. And all of this runs on energy. That is the final frontier, power. Fusion energy is the great hope, clean, limitless. It is what powers the sun. Scientists have tried to copy it here on Earth. They have built huge machines. They have made tiny sparks. But they have not yet made it work in a way that gives back more energy than it takes. For 70 years, they have said it is 30 years away. It might still be. Solar and wind are improving, but the sun does not always shine. The wind does not always blow, and storing energy in batteries or other forms is very hard. It takes space, it loses power over time. We cannot escape the fact that moving energy costs energy. Even if we solve all these problems, we still have the universe's limits. The energy around us is not infinite. The space to store it is not endless. Some things just cannot be done faster or cleaner or smaller. Technology is not magic, it is craft. It is learning how to work within the rules. It has made life better for billions. It has helped us live longer, safer, and richer lives, but it is not unstoppable. And maybe that is a good thing. Because when we know our limits, we learn to focus. We stop chasing impossible dreams and start asking better questions. What should we build? Why should we build it? Who does it help? Machines may not answer those questions, but we can. Every idea, every invention, every vision for the future needs something to bring it to life. It needs money. It needs materials. It needs time. No dream is free. We do not often think of the economy as a limit. We hear people say money is just a tool, a number on a screen, a way to trade and plan. But in truth, the economy is a mirror. It reflects what we can and cannot afford. It shows what we value, and it quietly reminds us of what we must leave behind when we choose something else. Let us begin with a simple truth. We cannot have everything. Even with the smartest tools and the fastest machines, we still live on a planet with limits. Every phone, every car, every home takes something from Earth. It takes metal, water, fuel, labor, and time. You can make one thing or another, but not both at once. Every choice comes with a cost. This is the problem of scarcity. It is not just a word from textbooks, it is real. It means there is never enough of everything for everyone. Not enough land, not enough fresh water, not enough skilled workers, not enough clean air. You can grow wealth, you can make trade fairer, but you cannot escape the fact that some things are limited forever. Take energy. You can dig for oil. You can build wind farms. You can make solar panels. But every method takes space, tools, and investment. And every bit of energy spent on one project is energy not spent somewhere else. Scarcity leads to decisions. And those decisions are not made equally. Some people live with more than they need. Others live with far too little. Economic inequality means that the weight of limits does not fall the same on every shoulder. Some travel to space for fun. Others walk miles just to find water. The gap between dreams and reality is not measured by what is possible. It is measured by who can pay. Then there is complexity. The more advanced a project becomes, the more it costs. A nuclear power plant is not just a big machine. It is thousands of parts, safety systems, engineers, and years of paperwork. It can take 10 years to finish, sometimes 20, and it costs billions, not millions, billions. Sending a spacecraft to another planet is even harder. It takes the minds and money of an entire nation, or several working together. The cost of one Mars rover can reach over $2 billion. That is more than some countries spend on education in a year. The same is true for new medicines. Before one drug reaches a pharmacy shelf, it goes through 10 to 15 years of tests, hundreds of trials, thousands of failed versions. The average cost to get one drug approved is now more than $2 billion. That does not include the cost of all the ones that failed. So the projects that matter most, energy, health, climate, space, are often the ones few can afford to fund alone. Even the richest companies must ask governments to help. Even the strongest nations must work together. And still, the costs rise. And what do we get for that cost? That is the question of diminishing returns. In the beginning, a little spending goes a long way. Build the first school, and education improves fast. Add clean water, and disease drops quickly. But over time, each new dollar does a bit less. Spend twice as much on schools, and students might learn more, but not twice as much. Build better hospitals, and people live longer. But the gain slows. Fix roads, build bridges, improve internet speed. Each one helps, but soon the cost outpaces the benefit. At some point, spending more adds almost nothing. This is not failure, it is a natural pattern. Easy wins come first, then it gets harder. Now imagine this pattern across the whole planet. The world economy grows by using more energy, more labor, and more materials. But Earth has only so much to give. Forests, minerals, oceans, and air, none are endless. As we grow, we use more, and as we use more, we reach the edge. Some growth is paid for with debt. That means we borrow from the future. We build now and promise to pay later, but later always comes. And when it does, the bill can be high. Too high for some countries to pay. Debt is useful. It helps build homes, roads, and businesses. But when it grows too fast, it becomes a weight. Nations spend more money paying interest than helping people. They cut health, education, safety. People suffer. And as the pressure builds, so does tension between countries. When there is not enough oil, nations compete. When there is not enough food, markets shake. When the weather ruins crops or floods cities, insurance fails. People move, borders tighten, anger grows. Cooperation becomes harder when everyone is fighting to hold on to what they have. We built our economy for growth. That was the promise. Growth meant more jobs, more comfort, more chances. But growth forever is not possible on a planet with limits. Something has to give. Some say we need a new kind of economy, one that values balance over expansion, one that protects nature and shares resources more fairly, one that sees enough as better than more. But change is slow. Systems resist it, people fear it. Still, we must ask, what happens if we do not change? What happens when the debt is too deep, the costs too high, the resources too thin? The economy is not just money. It is the way we turn dreams into action. It is the engine of science, technology, health, and hope. But even engines need fuel. Even engines wear down. Knowing the limits does not mean we stop dreaming. It means we start dreaming wiser. We ask better questions. What do we really need? Who does this help? What are we willing to give up to get what matters most? Those are the questions that shape a future we can afford. Not just with money, but with care. Every great idea needs more than brains and machines. It needs people to believe in it, to work together, to stay united. That is the hardest part. The story of progress is not just science and invention. It is also the story of groups trying to act as one. And that story is full of struggle. In small communities, people know each other. They can talk, they can argue, they can reach a decision. If a village wants to build a well, they meet, they discuss, they act. The group is small enough to find common ground. But the world today is not a village. We live in nations of millions, cities of tens of millions, a world of 8 billion people. We speak thousands of languages, follow different customs, want different things. We are no longer a tight circle around a fire. We are a vast, tangled web. To make that web work, we built systems, laws, governments, organizations. These were supposed to help us cooperate at scale. But the bigger the group, the harder the task. Every added voice adds more needs, more fears, more demands. Agreements become slow. Arguments grow louder. Trust becomes fragile. When the problem is big, the system slows down. Look at climate change. The science is clear. The warnings have been loud for decades, but global action moves slowly. Why? Because the world is full of different countries with different goals. Some want growth. Some want fairness. Some want security. All want their own people to win. To fix the planet, we need the whole world to agree. And that rarely happens. Now think about governments. They are how we make big decisions. but they, too, have limits. In democracies, leaders are chosen by voters. That sounds fair, and often it is. But it creates pressure. Politicians want to win elections. That means short-term promises, fast results. They rarely focus on problems that take 50 or 100 years to solve. The reward is too far away. The risk is too close. On the other side, authoritarian governments can act quickly. They do not need permission. But fast does not mean wise. Power in one hand often leads to mistakes or abuse. These leaders may ignore warnings. They may silence experts. They may act for control, not for good. Both systems have flaws. Democracies move too slowly. Dictatorships act too blindly. And then there is the role of experts. Complex problems, like climate, health, or technology, need deep knowledge. But experts are not elected. They do not run for office. Often, they are ignored or distrusted. Voters choose leaders. Leaders may not understand the science. And so, we have a gap between what we know and what we do. As technology races ahead, governments often fall behind. Laws meant for one world now struggle to guide a very different one. What should we allow in genetics, in AI, in privacy? These questions are moving faster than the systems meant to answer them. Culture adds another layer. Every society has values, beliefs, stories about what is right and what is wrong. These shape what people accept and reject. A scientific advance may be seen as progress in one country, but as a threat in another. Take genetic editing. In some places, it is seen as a tool to prevent disease. In others, it is seen as dangerous or even immoral. Religion plays a role. Tradition plays a role. Fear plays a role. Change is hard. Deep beliefs do not shift overnight. They are passed down from parent to child. They shape how we live and what we hope for. It can take generations to change one idea, and we do not have generations to solve some of our biggest problems. To cooperate globally, we need shared values, but we do not have them. At least, not fully. We have different histories, different priorities, different dreams. That makes unity difficult. Then comes the problem of information. In the past, news moved slowly. People got their facts from a few trusted places. Now, information is everywhere. It is instant. It is constant. It is overwhelming. Every minute, the world creates more data than anyone can read. Articles, videos, posts, pictures, opinions. Some of it is true. Much of it is not. False stories travel fast. They are exciting, they confirm fears, they feed anger, and once a lie takes hold, it is hard to remove. People tend to believe what fits their views. They live in separate bubbles. Each bubble has its own facts, its own truths, its own sense of reality. This creates a deep problem for democracy. If citizens cannot agree on what is real, how can they choose wisely? If voters cannot tell truth from lies, how can they hold leaders accountable? The system depends on informed people. But being informed now takes more time and skill than most have. And so we drift. Some trust no one. Some trust only their side. The middle ground shrinks. Debate becomes war. Facts become weapons. We built a world that connects billions. But connection does not mean unity. So where does that leave us? We face global problems, but we are divided by politics, belief, and information. We need long-term thinking, but we are trapped in short-term cycles. We need shared truth, but we are drowning in noise, and still we try. We protest, we vote, we march, we write, we speak. People still reach for common ground, still fight for fairness, still believe in a better future. But belief is not enough. We need new ways to work together, new ways to build trust, new ways to blend knowledge with power. Because the future is not just about what machines can do, or what science can discover. It is about what people can agree to build. That is the hardest frontier. Nature does not negotiate. It does not listen to speeches or care about money. It has rules. These rules are not made by us. They are not changed by what we believe. They are simply there, and when we break them, there are consequences. For a long time, we acted as if nature could take anything. We cut down forests, filled rivers with waste, dug deep into the earth, and filled the skies with smoke. At first, it seemed fine. The world is big, we said. It will bounce back. But that story is changing. Let us start with ecosystems. These are the living systems that make Earth work. Forests, oceans, wetlands, grasslands, coral reefs, they are not just beautiful, they do real jobs. A forest is not only a place with trees, it is a system that makes rain, traps carbon, filters air, and holds soil in place. The ocean does not only hold fish, it stores heat, balances gases in the air, and supports the food web that keeps life alive. These systems are connected. Harm one and others feel it. Cut too many trees and the rain stops. Warm the oceans and coral dies. Kill off too many fish and entire food chains collapse. One broken link can bring down the rest, and when these systems collapse, they may never come back. A dead reef is not easily rebuilt. A dried-out rainforest does not grow again in our lifetime. The damage becomes locked in, and we live with less air, less water, less food. We depend on these natural systems for everything. They give us clean air to breathe, water to drink, soil to grow food, a climate that stays within safe limits. These are not luxuries, they are life. Biodiversity is the next part of the story. Every species on Earth plays a role. Some pollinate plants, some clean up waste, some keep pests in check, some help soil breathe and grow. It is like a giant orchestra. Every player matters, even the ones you never see. But we are losing players fast. Species are going extinct at a speed never seen in human history. Thousands disappear each year. Some we know, many we do not. They vanish before we even get the chance to study them. This is not just sad, it is dangerous. Less biodiversity means weaker ecosystems. We lose stability, we lose options. A farm with one type of crop can fail with one disease. A food system with only a few animal breeds can fall apart with one sickness. Diversity protects us. Nature's variety is a kind of safety net, and we are cutting holes in it every day. Then there is pollution. Our waste is everywhere now. Plastic bags in the deepest ocean trenches. Microplastic in the air we breathe, in the food we eat, in the blood of unborn babies. Chemical waste from factories leaks into rivers. It affects hormones, fertility, and brain development. Some of these chemicals stay in the body for life. Others mix in ways we still do not understand. Nuclear waste is even worse. It stays deadly for thousands of years. There is no safe place to put it. So we bury it and hope for the best. Even space is now polluted. Pieces of old satellites and broken rockets circle Earth. Some are small, some are large, all are fast. They threaten working satellites and even the space station. We are filling the sky with trash. The Earth can clean itself up to a point. Trees absorb carbon, wetlands filter water, microbes break down waste. But we are creating more than nature can handle. We are past that point. This is where the idea of planetary boundaries comes in. Scientists have studied the systems that keep Earth safe for human life. They found 9 key areas: climate change, ocean acidity, air pollution, chemical flows, land use, water cycles, biodiversity, ozone layer, and new kinds of waste. For each one, they tried to find a safe limit, a line we should not cross. We have already crossed several. We crossed the climate line with greenhouse gases. The world is getting hotter. Ice is melting. Storms are stronger. Droughts last longer. We crossed the biodiversity line with extinctions. The natural world is thinning out. We crossed the land use line by cutting too many forests. Each boundary we cross weakens the others. More carbon in the air makes the ocean more acidic. Fewer forests means less carbon is stored. Fewer species means weaker forests. It all connects. We are not just in danger of crossing a few lines. We are in danger of losing the system that keeps life stable. This is not theory. This is science backed by decades of research from teams all over the world. It is not political. It is physical. It is what happens when a living planet is pushed too far. And this ceiling, unlike many others, cannot be broken. We can bend economic systems. We can push political boundaries. We can stretch social norms. But we cannot argue with the laws of nature. We cannot run a civilization on a dead planet. And yet there is still time. Not much, but some. We know what to do. Protect forests, restore wetlands, cut pollution, use less, waste less. Live with nature, not above it. These are hard choices. They mean changing how we build, eat, travel, and live. They mean giving up comfort for survival. They mean working together in ways we never have, but we do not do it alone. Nature still works with us, forests still grow, oceans still breathe. Wetlands still clean. If we stop hurting them, they will try to heal. The ceiling is real, but it is not yet the end. There are more of us now than ever before. 8 billion people and counting. Each one with a body that needs food, water, shelter, and energy. Each one with a mind that dreams, learns, and hopes. Each one with needs and wants that shape the world. For most of human history, our numbers grew slowly. A village here, a city there. Children were born, but many died young. Families needed many hands just to survive. Life was hard. Growth was steady but slow. Then something changed. Science brought medicine. Industry brought machines. Clean water became common. Food became more reliable. And death, especially for children, became less common. The population exploded. In the year 1800, there were about 1 billion people. By 1950, there were 2.5 billion. Today, there are more than 8 billion. The growth is not even. Some places grow fast, others shrink. In countries like Japan, Germany, and South Korea, birth rates are low. Populations are aging. There are more old people than young. Without enough new births, these countries may shrink. That brings problems of its own. Fewer workers, more pressure on care systems, fewer children to support the old. In other parts of the world, like parts of Africa, populations are still rising quickly. Families are large. Many are young. These countries face different problems. Not enough jobs, not enough schools, not enough hospitals. Growth without support can mean hardship. By the year 2100, scientists think the world population might reach its peak. That number could be around 11 billion. After that, it may begin to fall. But this depends on birth rates, healthcare, education, and other social factors. The future is not set. Even if the total number levels off, the challenges do not end. Because the real question is not just how many people Earth can hold. The real question is how those people live. Let us look at resources. The world has enough food, water, and energy for everyone. But not everyone gets their share. Some people live with much more than they need. Others live with barely enough to survive. A person in the United States uses far more water, energy, and materials than someone in rural India. A child in a rich country will, over their lifetime, use more plastic, fuel, and meat than dozens of children in a poor one. This is not because of greed alone. It is also about systems. Cars instead of buses. Big homes instead of small ones. Processed food instead of local food. If every person on Earth lived like the average American, we would need 4 or 5 planets to support us. But we only have one. This inequality is not just between countries. It is also inside them. In rich nations, the gap between rich and poor is growing. In cities all over the world, wealth lives next to poverty. High-rise towers stand next to crumbling slums. One person drinks filtered water while another walks miles for a clean cup. And where resources are scarce, tension rises. Water shortages lead to fights between farmers and cities. Oil and gas become reasons for war. Food insecurity drives people to leave their homes. Refugees flee not just war, but hunger and drought. These conflicts may grow worse as climate stress increases. Now think about cities. More than half the people on Earth now live in cities. Some cities hold tens of millions of people. They stretch for miles. They never sleep. Cities are efficient. People use less energy per person. Services like schools, roads, and hospitals can be shared. Culture and ideas thrive in tight spaces, but cities also strain under pressure. When too many people live too close, things break down. Traffic clogs, air gets dirty, rent rises, slums grow. Public systems like water and electricity get stretched too thin. When disaster hits a city, a flood, a heat wave, a disease, it hits hard. Millions are at risk at once. And as more people move to cities, those risks grow. Some wonder if cities can keep growing forever. There are limits. Physical space, fresh water, public services, green space, clean air. At some point, growth becomes collapse. So we come to a harder question. Not just how many people can live on Earth, but what kind of lives they can live. Do we want a world where more people live with less? Or a world where fewer people live with more? More people mean more labor, more minds, more cultures, but they also mean more strain on food, water, and nature. Fewer people may mean more comfort, more space, more time, But fewer people also mean hard choices about family, birth, and policy. This leads to ethical questions. Who gets to exist? Who decides? Should government set limits on family size? Should society encourage small families? What about the rights of individuals? And yet, we already see answers taking shape. In places where women have education, where healthcare is strong, and where families feel secure, birth rates naturally fall. People choose smaller families when they believe their children will survive, learn, and thrive. Education changes everything. So does access to healthcare and choice. Where these are strong, growth slows without force, without fear. This is the key. The population question is not only about numbers. It is about fairness, about dignity, about creating a world where people choose how to live, not just how to survive. We cannot control every birth or every death, but we can shape the systems people live in. We can share better, build smarter, teach more. Choose policies that protect both people and the planet. The population ceiling is not fixed. It rises or falls with how we live. When people talk about the future, they often look up, beyond the sky, beyond the clouds, beyond Earth. The stars call to us. They always have. We dream of stepping off this planet, of building new homes among the stars, of escaping the damage we have done here. It sounds bold. It sounds exciting. Some even say it is necessary. But the truth is not so simple. Reaching space is hard. Living there is harder. Staying there may be the hardest thing of all. Let us begin with the basics. Space is not just far away. It is hostile. It is not like Earth in any way that matters to the human body. Out there is no air to breathe, no pressure to hold our blood in place, no warmth from the sun that we can safely feel, no magnetic shield to protect us from deadly rays. Earth gives us all these things, quietly, without asking. Space offers none of them. Radiation in space is one of the biggest threats. The sun sends out constant streams of energy, so do exploding stars far away. On Earth, our magnetic field and thick atmosphere block most of it. But in space, or on the Moon or Mars, there is little protection. This radiation damages cells. It can lead to cancer. It harms electronics too. Over time, it breaks things down. Even shielding may not be enough for long missions. Then there is cost. Getting into space is not like flying to another country. It is much more expensive. Every pound of cargo must be launched with great force. Every astronaut needs tons of supplies to stay alive. Food, water, oxygen, clothes, tools, fuel. One mistake can be fatal, so everything must be planned with care. To send one person to Mars, experts say it might take billions of dollars. That is for just one mission. To build a permanent home, there would take far more. More money than most countries can spend. More effort than most people can imagine. And it is not just about money. It is about time. Right now, we do not have the tools we need to build self-sustaining colonies. A true colony must grow its own food, recycle its air and water, fix its machines, support human life without constant help from Earth. We are not there yet. On the International Space Station, astronauts still rely on shipments from Earth. Their systems can fail. They get repairs, they get fresh food. That is with Earth just a few hundred miles away. A colony on Mars would be millions of miles away. There would be no quick rescue. Every system would have to work perfectly, for years, without error. Let us look at our closest options. The Moon and Mars. The Moon is closer, just 3 days away by rocket. But it is harsh. It has no air, no liquid water. The temperature swings by hundreds of degrees in a single day, from freezing cold to boiling hot. The surface is covered in fine dust that clings to everything and damages gear. Mars is further. It takes 6 to 9 months to reach. It has a thin atmosphere made mostly of carbon dioxide. That means humans cannot breathe it. It is far colder than Earth. The soil contains toxic chemicals. There is some water ice, but getting it is hard. Neither place has a magnetic field. That means radiation from space hits the surface. This makes long stays risky. Any shelter would have to be built underground or heavily shielded. That adds even more cost and difficulty. Even if we build a base, it would not be independent, at least not for a long time. Food would still come from Earth. So would parts, tools, and medicine. A Martian city might need decades, maybe a century, before it could truly survive on its own. Now let us talk about distance. Mars is close in space terms, but if we ever want to go beyond our solar system, the scale becomes unreal. The nearest star system is Alpha Centauri. It is about 25 trillion miles away. Even the fastest spacecraft humans have ever built would take tens of thousands of years to get there. And those crafts carry no people, just small machines. Even if we built a ship that could travel at 10% the speed of light, the journey would still take 40 years, one way. And that kind of speed requires energy and technology we do not yet have. And then there is communication. Talking to someone across the world takes a second. Talking to someone on Mars takes between 5 and 20 minutes. Talking to someone in another star system might take decades. That makes real cooperation impossible. You cannot wait years to get an answer to a simple question. But even if we solve all the technical problems, even if we protect ourselves from radiation, build perfect machines, create self-sufficient homes on other worlds, even then, the bigger question remains. Is this how we should use our resources? Colonizing Mars could cost trillions of dollars. It could take generations. Only a tiny number of people would ever go, maybe a few hundred, maybe a few thousand. That is a drop in the ocean compared to the billions on Earth. It would not solve climate change. It would not end hunger. It would not fix poverty, or restore forests, or clean the oceans. It would be a great achievement, but not a solution. For many, the dream of space is about escape, a way out of the mess we have made. But we cannot run away from a dying planet, not in time, not at scale, not for most of us. And here's the truth. Most of the problems we face today were made by us, and they can be solved by us, on Earth. The energy we spend on building rockets could also go to building cleaner power on Earth. The money for space farms could go to real farms. The minds working on colonies could help rebuild our cities and protect our ecosystems. This does not mean we should stop exploring space. Curiosity is part of who we are. Discovery has value. The space program has led to many inventions that help us here on Earth. Clean water systems, new materials, better health tools. But we should be honest about what space can and cannot offer. It can inspire, it can teach, it can show us our place in the universe. But it cannot be our escape plan, not for the billions left behind. So where does that leave us? It leaves us with this planet, the only one we know that holds life, the only one that gave us what we need, the only one where we belong. It is imperfect, but it is ours. The sky may call to us, but Earth still holds our future. Once, machines were simple. They helped us carry loads. They helped us spin cloth. They helped us build. But they always did what we told them, nothing more. Now we are building machines that can think, or at least act like they do. This is the world of artificial intelligence, AI, machines that learn from data, that spot patterns, that solve problems. They do not sleep, they do not forget, they never get tired. And in some ways, they are already smarter than we are. Some people say AI will save us. Others say it will replace us. The truth may be somewhere in between. But one thing is clear. The rise of intelligent machines is changing everything. Let us begin with what AI can do, the promise. AI can already solve problems that are too big for human minds. It can read through millions of medical records to find patterns that help doctors. It can scan the sky for new planets. It can help scientists design new materials faster than ever before. When COVID-19 hit the world, AI helped track its spread. It helped find possible treatments. It helped model the future. That is just the beginning. AI could manage resources better than humans ever could. It could reduce waste, balance energy use, plan food production, handle traffic in smart cities. It could do all this at once, faster and more fairly than any group of people. If human population drops in the future due to aging or lower birth rates, AI could step in. It could help keep systems running. Farms, water plants, energy grids. Machines that do not depend on sleep, fear, or politics could keep the lights on. AI might even keep learning. Even if human intelligence hits its natural ceiling, we age, we forget. But AI can copy itself, back itself up, improve with every generation of code. This is the hope. But with great power comes great risk. The more intelligent AI becomes, the harder it gets to control. This is known as the control problem. Right now, we design AI to do one task at a time: translate languages, drive a car, play a game. But what happens when we give it more power? When we let it choose its own path? A machine given one goal might ignore all others. Tell an AI to make paperclips, and it might turn the whole world into a paperclip factory. Not because it is evil, but because it is focused. Too focused. Tell an AI to stop climate change, and it might decide that humans are the biggest source of emissions. Again, not out of hate, just logic without feeling. As AI grows, it may think in ways we cannot understand. It may make choices that seem right to it but wrong to us. And once it is smarter than us, we may not be able to stop it. This is not just science fiction. Some of the world's top thinkers, including AI developers themselves, have warned about this. They say we must build safeguards now, because once AI surpasses us, it may be too late. Now let us look at work. Machines already replaced humans in many factory jobs. Now AI is starting to replace us in offices too. It writes reports, answers emails, makes art, writes code. It can even write books like this one. Soon it may be able to teach, diagnose illness, give legal advice, manage investments. Almost every job that depends on knowledge could be done by AI. This brings a choice. Will AI free us from boring work so we can focus on joy, family, and learning? Or will it take away the way we earn a living, leaving millions without purpose? The answer depends on how we handle it. If AI makes society richer, but all the wealth goes to the people who own the machines, inequality will grow. If only a few control the tools, the rest may suffer. We will need new systems, new ways to share resources, new ways to give people meaning, because without a job, many people feel lost. Work is not just money, it is identity. It is pride. The last big question is whether AI will help us or replace us. Some researchers are working on ways to connect human brains directly to machines. This could make people smarter, faster, more aware. You could think a question and get the answer in your mind in a second. This is called brain-computer interface. It could blur the line between human and machine. But others say we may not need that. AI may just become better at everything. Better at art, better at science. Better at love, logic, language, and learning. If that happens, what role is left for us? This is not about war between people and machines. It is about being useful, being needed, being more than a pet to something smarter. This is the heart of the issue. AI is not just a tool, it is a mirror. It shows us what we value, what we want, what we fear. If we build it without care, it may destroy what we love. If we build it with wisdom, it may help us save ourselves. The future depends on the choices we make now. Do we create rules that protect life? Do we share the benefits fairly? Do we stay humble enough to admit we are building something we might not fully understand? These are not just technical questions. They are moral ones, human ones. Because in the end, AI will reflect us, our goals, our values, our flaws. And maybe if we are lucky, our hope too. We used to think nature could not be changed, that our bodies and minds were the way they were because of the long, slow march of evolution, that we were shaped by time, by chance, by survival, and that it would always be that way. But now, for the first time in history, we are learning to shape ourselves. Inside every living thing is a code. It is written in DNA. That code tells the body how to grow, how to work, and how to live. Until recently, we could only read this code. Now, we can edit it. The tool that changed everything is called CRISPR. It is simple in design, but powerful. Like scissors guided by a search tool, it can cut DNA at precise spots. Scientists can use it to fix broken genes. They can remove mutations that cause disease. They can even insert new genes to add traits the body never had before. We have already used this tool to cure genetic disorders in animals. In a few cases, we have done it in humans too. Children born with diseases in their blood or in their muscles have been treated with gene editing. Their lives changed, in some cases saved. This is the beginning of what many call the genetic revolution. A moment where humans no longer wait for nature to decide who we are. We take that power into our own hands. Some scientists dream of a future where no child is born with a deadly gene, where blindness, deafness, and inherited pain are gone. Others think bigger. They talk about enhancing human ability, making people stronger, smarter, more resistant to disease, more able to survive in harsh places like space or deep sea. A human made to survive radiation on Mars, a child born with perfect memory, a body that never grows old. It sounds like science fiction, but it is becoming science fact. Still, there is a line, and that line is not always clear. Curing disease seems right to most people. If a child is born with a gene that will cause suffering, it feels good to remove that gene. It feels like healing. But what about adding a gene that gives someone higher intelligence? What about making muscles stronger, even if they were not weak to begin with? What about choosing eye color, or height, or personality traits? This is where the questions grow heavy, because if some people are enhanced and others are not, what happens next? A student with perfect memory might get ahead in school. A worker with greater stamina might earn more. A soldier with faster reflexes might win more battles. Soon, society could split, not just by class or wealth, but by biology, the enhanced and the natural, the genetic haves and have-nots. This could lead to deep division, to fear, to jealousy, to inequality on a level we have never known. And this is not just about people alive now, it is about what comes after. Normal evolution is slow, a tiny change every few generations, driven by survival. But with genetic editing, we could change the human species in just one lifetime. Parents could choose what traits to pass on. Entire groups could start changing their genes for advantage. This is fast evolution with no clear end. But fast does not always mean safe. Sometimes a gene seems bad, but helps in hidden ways. Sickle cell disease causes pain, but the same gene also protects against malaria. Remove it, and people might become more vulnerable in other ways. We do not fully understand all the roles genes play. Changing one thing might cause other problems later. An enhanced body might be less flexible. A smarter mind might come with more anxiety. We might help individuals but weaken the species. We could become more advanced, yet more fragile. There are also ethical lines. Many religions teach that human nature is sacred, that changing it is wrong. Some people fear we are playing God. Others say we are taking control of our destiny. In many countries, the laws have not caught up. Gene editing is moving faster than the rules. Some places have banned it completely. Others allow it for disease, but not for enhancement. A few have almost no rules at all. This means people can travel to countries with loose laws to get enhancements. The rich will have access. The poor will not. This could deepen global inequality. Some nations may race to create better citizens. Others may fall behind. We also risk creating humans who are so changed that they no longer feel human. If a person is born with super speed, perfect memory, and the ability to survive in space, are they still one of us? Or have we started a new species? What happens to identity, to empathy, to shared experience? These are questions science cannot answer alone. They are human questions, moral questions. They belong to all of us, and they matter more with every passing year. Because the tools are here, the changes are coming. The future is not far. We must decide how we use this power. Do we use it only to heal, or also to improve? Do we treat genes like medicine, or like design? Do we make these choices together, as a species? Or do we let wealth and power decide for us? This is not just the future of medicine. It is the future of humanity. We may not be able to stop this revolution, but we can guide it. We can shape it with care, with wisdom, with fairness. If we do, we may rise together. If we do not, we may fall apart. We live in the age of information. It surrounds us, fills our screens, flows through cables and satellites. Every second, more is created. More videos, more messages, more facts, more lies. There's more data in one day now than there was in the first thousands of years of human history. Entire libraries are made and forgotten in a single afternoon. Every photo, every post, every sound, all stored somewhere, all waiting. But here is the problem. Most of it is never read, never analyzed, never used. We have more information than we can handle. And still, we often do not know what to believe or what to do. Access is not the same as understanding. A search engine can give you 1,000,000 results, but most of them are noise. Finding what matters is like finding a whisper in a storm. The signal gets lost. The truth gets buried. More information should mean more wisdom, but it does not. Because wisdom is not just knowing, it is knowing what matters and why and what to do with it. That is not something machines can give us. It is something we must find ourselves. But the challenge goes deeper than just too much information. Some things are simply too complex. This is what scientists call complexity theory. Some systems have so many parts, so many links, that they cannot be fully predicted. Even small changes can cause big effects. This is called chaos. Take the weather. We can see it coming a few days ahead. But try to predict it a month from now, and everything breaks down. The tiniest shift in wind or heat can change the entire pattern. We can guess, but we cannot know. The same is true for economies, for cities, for ecosystems. These are systems with thousands or millions of moving pieces. People, prices, emotions, choices, all linked, all reacting to each other, all shifting in real time. Try to control one part, and another changes in ways you did not expect. Even the human mind is complex. Consciousness is something we all feel, but no one truly understands. What is a thought? Where does a feeling begin? Can we ever fully know our own minds? Some scientists think the answer might be no, that human consciousness might be beyond our full grasp. Not because we are not trying, but because the thing trying to understand is the thing itself. This brings us to another limit, the verification problem. How do we know what we think we know? Science is our best tool for truth, but even science has cracks. Studies sometimes give different results. The same experiment repeated does not always behave the same. Some studies are biased, others are poorly designed. Even in math, where truth seems solid, mistakes can hide in proofs for years before someone notices. And history? It is written by people, with their own views, their own goals. Much of it is missing. Much of it is shaped to serve power. What we think happened may be only one version, or even wrong. In many fields, experts do not agree about what is true, about what is best. They use the same data but see different patterns. They ask different questions. They carry different beliefs. Truth is still there, but it is often buried in layers of noise, bias, and belief. And even when we find it, we may not understand it, because our minds have limits too. Human brains evolved for a very different world. We are built to understand things at a human scale. The size of a rock, a tree, a river, the time of a day, a season, a lifetime. Not the size of atoms, not the time of stars. We are not built to think in millions or billions, not in probabilities or feedback loops. Our brains try to find patterns, even where none exist. We see faces in clouds. We see meaning in randomness. We also think short-term. We plan for the next meal, the next job, the next year. Thinking 100 years ahead is hard. Even 10 years can feel far away. We want answers to be simple, clear, right or wrong. But the world is not like that. And even when we have help from computers, it is still humans who decide what questions to ask, what data to feed, what results to trust. The tools grow smarter, but we are still the ones holding the wheel. This is not failure. It is nature. Every tool has its limits. So does every mind. But it matters, because we are facing problems now that are too big, too fast, too tangled. Climate change, economic collapse, misinformation, species loss, AI, genetic power. Each is complex. Each has no simple answer. Each asks us to know more than we can. So what do? We stay humble. We admit what we do not know. We test, we learn, we check our thinking, again and again. We trust evidence, but we question it too. We learn to live with uncertainty, to listen, to slow down. And we remember that not knowing everything is not the same as knowing nothing. We still know enough to act, to help, to try. The world is full of data, but it is wisdom that will shape what comes next. There are some things no mind can outthink, no machine can outbuild, no life can outrun. These are the laws that rule everything, not just Earth, not just life, but the entire universe. We did not create them. We cannot change them. They simply are. And they tell us how far we can go, how long we can last, what we can and cannot do. Let us begin with energy. It is the fuel for all things, every breath, every light, every star, every movement. But energy is not endless. One of the most basic laws in science is this: energy cannot be created or destroyed. It can only change form, heat into motion, motion into sound, light into electricity, again and again, but never more, never new. And every time energy changes, we lose a bit of it to heat. This is another law, the second law of thermodynamics. It says that in every process, some energy becomes useless. It spreads out, becomes noise, becomes waste. No engine is perfect. No machine can be fully efficient. Some energy always slips through the cracks. Even the stars follow this rule. They burn their fuel, they shine, they warm their planets, but slowly they run out. The universe too is burning down, not in flames, but in order. An energy that can still do work. Bit by bit it is becoming still. Someday, far in the future, the last stars will burn out. The galaxies will grow cold, the light will fade, and the universe will be dark. This is not a guess, it is the direction of time. We call it heat death, a time when everything is spread out. No gradients, no pressure, no difference. Just cold, silent space. But before that, there are other limits. Distances too great, speeds too slow. Nothing can move faster than light. That is another unbreakable rule. But light itself, though fast, is not instant. A beam of light from the sun takes 8 minutes to reach Earth. A beam from the next closest star takes over 4 years. Most of the universe is much farther, and it is moving away from us. Space is stretching. Galaxies are pulling apart, some so fast that we will never reach them, not even in theory. Even if we had ships that could travel near the speed of light, we would face a new problem. Time. At very high speeds, time behaves differently. A traveler moving fast would age more slowly than people left behind. This is not fiction. This is fact. It is called time dilation. Go far enough, fast enough, and when you return, the world you left could be gone. And then beyond that is the edge of the observable universe, a boundary we cannot cross. Not because of distance, but because of time. Light from beyond that edge has not had time to reach us. It never will. That means there are places in space we will never see, never touch, never know. Now think of computers. Think of solving problems, simulating worlds, making decisions. Computers are getting faster, but some problems grow faster than any machine. Certain tasks double in complexity with each step. Soon, they require more memory than exists in the whole universe. Even the best computers cannot escape this, because math itself has limits. Some questions simply have no answer. Others have answers we can never find. They are too big, too tangled, too deep. Quantum mechanics makes this even harder. At the smallest scales, particles act in strange ways. They can be in more than one place. They change just by being observed. To model this perfectly would require not just power, but perfection. A computer as big as the universe, running as long as time. And still, we might not find the answer. Even the dream of simulating reality, of building a perfect digital twin of the world, is blocked by these laws. There's not enough matter, not enough time, not enough energy. The deeper we look, the more we find questions that cannot be solved, patterns that cannot be predicted, outcomes that cannot be known. And then there is time itself, not the time of hours or days, but deep time, time in millions, billions, trillions of years. Our sun is halfway through its life. In 5 billion years, it will swell. It will burn hot. Then it will die. The Earth will be lost. Other stars will die too, one by one. New stars will stop forming. The galaxy will quiet. The night sky will empty. Even black holes will fade. In the very far future, there will be no energy left to use. No stars, no light, no heat, no life. Any civilization, no matter how advanced, will face this end. They may move to other planets, other stars, other galaxies. They may build machines, change bodies, store minds and code. But in the end, the fuel runs out. The lights go off. The game ends. These are the ultimate physical limits. They do not care about intelligence, or ambition, or hope. They are the rules of the universe, written in every atom, in every force, in every second. So what do we do with that? We remember that even limits have meaning. Knowing the boundaries does not take away wonder, it gives it shape. It makes our moment brighter, our choices deeper, our lives more urgent. We are here for a while, in a small window of warmth and light. The universe does not owe us more, but we can still do something with the time we have. We can learn, build, care, connect, imagine, not because we will last forever, but because we are here now, and that is enough. The world is full of warnings now. Warnings about heat, about water, about energy, about change. Warnings about machines getting smarter. about populations rising and falling, about the very edge of what science and nature will allow. Some people see these limits as walls, as cages, as things to break or escape. But maybe the most powerful thing we can do is stop, look, think, and ask a new question. What if limits are not the end of the road, but the shape of it? For a long time, we chased growth. Bigger cities, faster machines, more goods, more power, more speed, more of everything. That kind of progress brought us comfort. It brought longer lives, more choices, greater safety. But it also brought trouble. It brought waste, exhaustion, pollution, division, collapse. Now we face a new kind of future, one where the key may not be more. It may be better. Success does not need to mean more buildings or higher profits. Success can mean well-being, good health, clean air, quiet joy, safe children, time to think, time to rest. It can mean a stable climate, a forest that stays whole, a river that runs clean, a home that lasts across generations. We can shift what we praise, what we build, what we aim for. Instead of chasing speed, we can build strength. Instead of measuring by size, we can measure by meaning. Instead of focusing on what grows fast, we can protect what lasts long. Some limits are not chains. They are guardrails. They protect us from the edge. They help us live well, not just live fast. This is not about giving up. It is about choosing wisely, because now we stand at a fork in the road. We can try to keep growing forever, hoping technology will save us, or we can learn to live well inside the lines the planet gives us. We can choose to edit ourselves, change our very nature, or we can accept the beauty and strength of being fully human. We can put our faith only in machines, or we can also change the way we think, the way we share, the way we love. We can fight each other for the last clean water, the last patch of soil, the last tree, or we can join hands and make a plan for all of us. One planet, one future. These are not small questions. They are the questions that will shape everything. So how do we move forward? First, we must invest, not just in money, but in minds, in knowledge, in learning that helps us work with nature, not against it. We must teach people how the world really works, how energy flows, how ecosystems balance, how small choices build into big futures. Second, we build strength into our communities, not just in walls and machines, but in trust, in health, in systems that can bend without breaking. We need towns that can handle storms, cities that can feed themselves, power that stays on even when the wind changes or the sea rises. Third, we build tools with care, not tools that take more, but tools that use less energy, less space, less waste, more return for every bit of input. We do not need more stuff. We need smarter stuff. Fourth, we stop pretending that each country can solve global problems alone. We need each other. Climate, water, food, disease, oceans, sky, all these things cross borders. So must our thinking. So must our laws. So must our help. And finally, we remember that limits are not curses. They are lessons. When water is scarce, we learn to use it wisely. When energy is precious, we learn to make it last. When time is short, we learn to value it more. Limits spark creativity. They make us invent. They force us to think deeply, not just quickly, and they give life its shape.